Hey everyone, this is Nix with East Canada Fire Alarms. In this video, I'm making a very important video, especially for beginners in fire alarms. I'm here with the Shed Productions.
Hello.
So, this is the Fire Alarm Buyer's Guide. Updated version, because the last one that was made by another YouTuber whom, for reasons I don't want to get sued, I will not name. That video series is very outdated. A lot of bad information, in my opinion. So I will make one as detailed as I can, and I will explain everything properly. So, this video is one video that will have multiple chapters. So, it should be pretty detailed for you guys, especially beginners. And as you can tell, this video is not scripted, so what I say is what I think on the spot. So, with that, we will begin. Alright, so here's chapter 1. Horn devices. I love to call them noisemakers because that's literally what they do.
Or notification appliances.
That's the proper term. So, this may look overwhelming to you because there's many different choices. This is a horn-only device, by the way. There's a strobe cover, but there's no actual strobe inside. So, as you can see, there's American devices. I have one European sounder as well. They all work the same. You apply power and they make noise. So, ideally what you want are 24-volt DC devices like all of these here are. There's many different voltages, but if eventually you want to get a panel, fire alarm panels are 24 volts DC. And later on I'll explain the differences between some panels where they output what's called filtered DC and what's called full wave rectified. So to start with horns, this right here is an old mechanical horn, but you just need to apply positive and negative 24 volt power to it, and it will make noise. It will sound off. Same goes for this. This is a Panalarm Novatone. It's not a fire alarm device, but since it's 24 volt DC, you can use this on fire alarm panels. As you can see, I have a positive and negative wire coming out, and just plug it in to 24 volt power and it makes noise. Again, this is a system sensor Spectre alert. This is in the community known as the Classic Spectre alert, except their classic name is not official. This one's a first generation, and this one, it's not easy to see, but there's terminals on the sides. You can see a positive symbol and a negative symbol. You just apply a positive and negative 24 volts DC, or in this case, this one can also do 12 volts. Some alarms have multi-voltage capacity. So this one can go from 10.5 volts up to 30 volts DC. Hence why we call this a 12/24 volt alarm. Some of them have options as well. As you can see, this one can self-code or do continuous, tone change, and high and low volume. This right here is a first generation Edwards Genesis. Just like the other ones, there's two terminals, a negative and a positive. So they all work the same way. Here's a fully on Roshni European sounder. And just as you can see, so it has two positives. They're connected together internally, so it's just like one positive. and 2 sets of negatives, because first sound is the main tone you set. Second sound is a secondary tone that you cannot change. But same principle, if you put it in positive, which is called common on this one, and negative first sound, it's just going to make noise. There's nothing else to it. So yeah, horns are pretty simple. You apply power and they sound off. Some horns, like mechanical horns, will sound very good on filtered DC, but on full wave rectified power, they will sound really weird. Full wave rectified is only half of the AC sine wave, so you're cutting out the negative wave of it. But it's AC wave goes like this, so you're cutting out the negative part of it, so it just goes flat like this. So the horn only sounds on the positive cycle. Meanwhile, a DC wave is just flat. There's no wave to it, so it sounds continuously. Alright, so here is chapter 2 of the video, horn strobes. Now we're going to get into a deeper territory with these because there's a good amount of differences between each horn strobes. But they all do the same thing in technical terms. They all flash and make noise. So as you can see, there's many different types, including wall mount and ceiling mount. Difference is that wall mount, the lettering will be viewable when it's mounted on a wall, and the strobe will be able to flash correctly mounted on a wall. Meanwhile, ceiling devices are made to go on the ceiling. This example right here does not have any fire lettering, but the strobe is made to be mounted up on a ceiling, so it can be viewed in a 360-degree angle. Now, there's 2-wire versions, and there's 4-wire versions. So the difference between those is that 2 wires, you can see there's only 2 wires, positive, negative, which means the horn and strobe internally are connected together, so applying power will make both go off. Now, if that's not a problem for you, that's fine. You apply power, it makes noise and it flashes. But if you're with your parents and they find alarms to be annoying, maybe you want 4-wire horn strobes, where you can control each part separately. As you can see, this one says strobe, positive, negative, and horn, positive, negative, because this one, if you apply power only to the strobe terminals, only the strobe will flash, so it's not going to make noise. If you apply power only to horn terminals, only the horn will sound, so the strobe will not flash. If you apply power to both the strobe and horn terminals, both the horn and the strobe will sound off. Again, most of these devices are 24 volts DC, so that's what you want ideally. So these are pretty easy to wire up. It may look complicated at first, but it's just a positive, negative for the strobe and positive, negative for the horn. Same thing goes for this wheel-lock alarm. STB for strobe, plus minus. Odd for audible, which is the horn, plus minus. This one also has selection, volume, and tone. This is a wheel-lock multi-tone alarm. This one is a Mercom alarm. Still has some selections here. This is a multi-candela, which means you can change the brightness. Except this one's not a good example of a multi-candela alarm. This one's much better example, so I will show you how that works. So here, as you can see, this is a high candela model. So it goes from 95 candela minimum all the way to 177 candela, selectable by a switch. Just move this piece around. So it changes the brightness of how bright the strobe flashes. This one's made for very large environments where you need a high output strobe. Normal horn strobes, like this one here, will have all the way from 15 to usually, I believe, 110 candela. Some of them, like this one, can go up to 185 candela. I will get a much easier horn strobe to open to show you this. This is a system sensor spectre alert, also known as the classic spectre alert in the community. As I mentioned earlier, it is not the correct term for these. It's just spectre alert. So here's your candela switch. This one has a little window on the side. So as you can see, 15/75, which what that means, if you're viewing the strobe directly, it looks like 75 candela, which is pretty bright. Reflecting on the walls, on the sides, it's only 15 candela. I don't know how that works, but that's how that works. 30 candela, 75 candela, 110 candela. So this one goes up to 110 maximum. So it just changes how bright the strobe flashes. So the bigger the number, the brighter it is. I'm just going to close this back up later.
Right, and 4-wire ones are more likely to be able to be coded rather than 2-wire horn strobes.
Yes, I forgot to talk about this. So some alarms can self-code, like this one right here can do non-temporal, which is continuous, or temporal, which is what people call code 3. The real term for it is temporal, or temporal 3. Continuous just makes a continuous noise. It does not stop as long as you have power. Temporal 3, it pulses the horn. And I will demonstrate that a bit later in the video, because I will be talking about coding. So, yeah, when you have the horn strobes, well, the horn part, or horn-only devices as well, on continuous, you can code them with your panel if you have one. So, that's the fun of it. So, this is chapter 3, strobes and visual devices. So as I explained earlier with horn strobes, strobes flash. So this is a strobe only device. In my case, this one is 120 volts AC, so it takes pretty risky voltage levels. Not something I recommend for beginners. Get a 24 volt DC device. This right here is a Space Age V33 flashing light. Some are steady and they also come in strobe versions. Mine, it's a light with a flasher. Just like other devices, this takes 24 volt DC voltage. And it's just a 2-wire device because it only makes light. So you can see 2 terminals, positive, negative. Strobe only devices also come in 2-wire versions. Obviously not 4-wire because they only have a strobe. So there's not much to these really. Apply power and they make light. So this chapter is pretty short. Also, unlike strobes, lights like this do not have a brightness selection. They only have one brightness. Also, I'd like to mention that not all strobes have a brightness selection. This one right here, there was a sticker on it. This one is 110 candela, fixed, so you cannot change it. But on some devices, as I explained earlier, you can change the brightness. Like this one's on 15 candela. So yeah, just want to let you guys know that some strobes can change brightness, some you can't. These Edwards ones, Edwards Integrity, you cannot change the candela, but on these Edwards Genesis devices you can. The second and no, only the third gen devices. Second gen are fixed. But for example, this Space Age V33 light right here is a light. It's not a strobe. Although it has a flasher, so it blinks, but it doesn't flash like a strobe. It's a slow blinking. There's also continuous lights like the Simplex 2903 light plate. And I will be getting to strobe and light plates in this next chapter. Alright, so this is chapter 4, strobe plates. So what's special about these? As you can see, they're very big and they have a strobe on them. But why the holes right here? That is because you can mount horn-only devices on these and make it so you turn it into a horn strobe. Also, you can do bells, which I will explain bells in the chapter after this one. So for example, if I get my Green mechanical horn from earlier, I can mount this like this on here, and now I have a horn strobe. Same goes for this one. Now I have a horn strobe. Both of these strobe plates are made by Wheelock, but there's Edwards, there's Simplex, which Simplex has really weird things about them. But yeah, this is just a strobe with a larger plate, so you can mount a horn or a bell on it to make it a horn strobe or a bell strobe. Can also demonstrate with a bell, as I have one right here. It would go like about like this on the strobe plate. So here we are at chapter 5, bells. As you can see, there's differences between those as well. These, ideally, you want to get 24 volts DC. This one in the middle is a 12 volt bell. So if you have a 12 volt panel, you can get 12 volt devices as well. And this can run on intrusion panels if you have one. But this video is about fire alarms, so I will not get into intrusion panels too much. As you can see, there's different sizes. The sizes are unfortunately measured in inches. I'm not a fan of inches, but that's what it is. This is a 6-inch bell, pretty small. They also come smaller. There's 4-inch and I believe also 3-inch bells. So this one's a Cerberus Pyrotronics, pretty old one. Makes this sound. So the pitch differs from brand to brand. So I mean, while this one is higher pitch, another 6-inch bell like this Potter right here is lower pitch. So bells, the way you mount them, unscrew this nut right here and you remove the gong. and you have your mounting holes. And they connect via pigtails, so positive, negative. Usually they have 2 sets of red and 2 sets of black wires. They're just connected together internally. It's an in and an out to go to your next device. So now we're gonna go on to the 8-inch bell. Slightly bigger, also louder. So the size affects volume on bells. This one, as you can see, is a nice lower pitch. This one's 8-inch. It's also a good bit heavier. Bells use a striker. This one you can actually see the striker very well. Bells use a striker like this, which will hit the gong at very, very high speeds, which rings the gong like this, making noise. This one is non-polarized, which some old devices, this bell's older than me by a very big bit. Old devices like this will not have polarity, but if you want to use them on a fire alarm panel, you will have to add a diode to polarize the device. You can look up online how to use diodes. It's not very difficult at all. Now onto the 10-inch bell. It's obviously bigger than the 8-inch bell. Works the same as other bells, except it's bigger, lower pitch, and also louder. So for very big areas you want to use 10-inch bells, and for very small areas you want to use 6-inch bells. 8-inch bells are a very rare thing to find. I have never seen them in the wild. I'm quite lucky to actually own an 8-inch bell, because they're extremely rare. Here we have Chapter 6, Silenceable Mini-Horns. This is a Canadian thing, and since I'm Canadian, I want to explain this, because US collectors, you can get these on eBay sometimes. So I want to explain how they work, and where you would see them installed here in Canada. You will never see these in the US, because the US does not allow these devices. So, these are mini horns, so they sound like a smoke alarm. You cannot change the tone. And they have a press to silence button. This one's really obvious. It's the square rectangle button. These two system sensor ones right here, it's the little light lens right here. So what do these do? When they go off and you press the silence button, it silences them for 10 minutes. After 10 minutes, they sound back off. So where would these be installed? They will be installed in apartments and condos, or in some cases hotel rooms as well, if the system is conventional. So this allows you to silence the alarm only locally. Only if you press silence on the device, only silences that one device. So if you know it's a false alarm, you've confirmed it's a false alarm, you can silence it while the responsible people go silence the system. So it's less annoying to hear, because these are, while they sound like a smoke alarm, obviously they're quite loud and annoying. So it only allows you to silence them temporarily. If you know it's a false alarm, or if you're very stressed sometimes, and I don't recommend it, but some people do it, when people prepare stuff to go outside in evacuation, they sometimes silence it, but I don't recommend that. If a fire occurs, the alarm sounds off, you need to evacuate immediately. Do not take your stuff, just leave everything and get out. Because I see a lot of people just waste their time before getting out. In a real fire, seconds matter. It's a huge difference between life or unalivement. So These, you want to press silence only if you know it's a false alarm, or also if the inspector is there and the alarm's going off because of an inspection. That's all I have for this. These are 2-wire only devices. They're just horns with an extra feature. Alright, so here's chapter 7. As you can see, I put a lot of devices out because this chapter is the notification appliances that I recommend for beginners. This is strictly my opinion, so do not comment anything stupid, because my opinion is my opinion and it may not be everyone else's opinion. I am basing my opinion on how easy the devices are to use. So here I will start. First off, this device again, the Wheelock MT. This one is an MT12 LSM. It's a 12 volt model, but I recommend 24 volts a lot more. This one, I love this alarm because of how easy it is to wire. It's a 4-wire device, so as I explained, strobe and audible. This one has a volume adjustment, which is this first dip switch here. And then the 3 other dip switches here are tone selection. This alarm can make different sounds, which is why I like this alarm a lot. It's also a very, very iconic alarm in the community. A lot of people will recommend these, and I agree with them. It's a good alarm. Very solid alarm. Next up, this thing again. Silenceable Mini-Horn, or just a normal Mini-Horn. Because yes, Mini-Horns without silence feature exist. It's just a horn that sounds like a smoke alarm. And it's small. These are easy to use because they're just 2-wire. These system sensor ones can self-code as well, which I like a lot. So if you don't have a panel to code them, or your panel you have cannot do coding, these system sensor Mini-Horns can self-code. Next up, this Mercom FHS 400. This one's a horn strobe. There's horn only versions and there's strobe only versions. These alarms are very, very high quality for a modern LED horn strobe. They're easy to install. These ones only come in 2-wire variants though. They can do a lot of codings for what they are compared to some other alarms. They can do continuous, temporal, 60 beats per minute march time, and 20 beats per minute. They're also extremely loud, so don't forget hearing protection, and that goes for any alarm. They're very solidly made. The plastic on them is very thick. It feels very nice. It's an alarm I just recommend a lot. It's also multi-candela, so you can change the brightness. So yeah, I recommend these all day, every day. Next up is another iconic alarm in the community, the System Sensor L series. They come in 2-wire, and in my case, this one is a 4-wire version. So you can control the strobe and the horn separately. These are dual tone alarms, so you can either have it sound like the normal well-known Spectre or the Advance, or you can make it sound like a smoke alarm. This model is P4RLA, the A, it's Canadian, and this one's bilingual. As you can see, this is a 4-wire base, so the first 3 terminals are for the strobe, last 2 terminals are for the horn. This one can also do temporal and continuous, and coded. Now, on system sensor devices, why is there continuous and coded? Continuous is, it's your long continuous tone, except it does not sound immediately when you apply power. that does not allow you to code the panel, which is why they have coded. Coded is continuous as well, but as soon as you apply power, there's no delay, the horn sounds. Now you only see coded on 4-wire horn strobes or the horn only devices. Because obviously 2-wire horn strobes, you do not want to code them because the strobe will go weird.
True.
And both me and him can confirm that. So this alarm, it's not as solid as the Mercom, although it's still pretty decent, and I recommend it. It's a good alarm. Next up, we're going to the vintage stuff. This is a Pyrotronics, but well known as Wheelock, 7002T. The most iconic mechanical horn strobe in the community. So, this one's 2-wire. It does the most well-known strobe skipping. It's completely made of metal except for the strobe part. And it sounds nice on filtered power. Sounds weird on full wave rectified. Because that's what mechanical horns do. It's a solid alarm, and I recommend it. Going back into the modern stuff, for now, the Mercom FHS 240 series, which also come in a horn only or strobe only version. The horn strobe versions are strictly 4-wire, so you can control the strobe and the horn separately, which is nice if you want to only use the strobe for certain circumstances. These alarms, I will say, they're not that loud, but still wear hearing protection. So you can change the coding, so this one does continuous or temporal. The continuous on this particular device is instant. You can do electromechanical or 3K hertz tone, high volume and low volume. It's not as good quality as the newer Mercom stuff, but it's still a good horn strobe to have. Especially if you want a 4-wire device. Next up is the ceiling mount Edwards Genesis, or the wall mount versions are basically similar. 2-wire, as I explained earlier. These do not come in 4-wire, at least for a ceiling mount. For the wall mount devices, you can get a 4-wire module that you can add. It's weird how those work. And those modules, I believe, are quite hard to find. And very expensive when you find them. So, these horn strobes are extremely loud. Always wear hearing protection, just like the other devices. But they're an iconic device. They're very well known. And they're okay. I'll say they're not the highest quality, but they're okay. Last up, for these devices I recommend, usually what's known as the simplex, forgot the model number beginning, but ends with 9838. This one is a very, very rare rebrand by Parine, known as the 6124G. It's a 2-wire horn because there's no strobe. It's a mechanical horn, so it's very old. It sounds nice if you have a filtered DC panel. Or any DC power supply you can find, 24-volt DC will be filtered. There's no standalone power supply that is full wave rectified, as far as I know. So on a standard 24-volt power supply or filtered panel, these will sound great. They will sound very nice. Fully made of metal, so they're solid. And you can't really go wrong with these. Chapter 8, Pull Stations. There's not much to these. Conventional pull stations, they don't involve a lot. They're just a fancy light switch. when you pull them, it just closes the contact. So I'll go over a couple different devices and show you the differences. So we have what we call tab style pull stations, like this one right here and these two right here. What tab style is when you pull them, it pulls on this tab, which releases the whole front, which depresses the button and closes the contact, which would create an alarm. It's just a switch, just a fancy switch. To reset them, you put a screwdriver in and you pry up while pushing on the cover. I'll demonstrate with this one, as this one can take a bigger screwdriver. Pull like this. Insert screwdriver, push on the cover, pry up, it closes, and pull it out. They're very simple. There's not much to these. They're good if you know how to use them. Like, they're easy to learn how to use them, reset them. And they're very simple to pull, except some of them, like this mirror tone one right here, is super difficult to pull. And this one resets with a screwdriver at the top. I don't have a screwdriver for it right now. At least I don't think this small one will work. These take a pretty beefy screwdriver. Oh, it worked. There we go. That's how this resets. Next we have T-bar style pull stations, like the Simplex right here, and this RSG T-bar, which this one is branded by Firelight. So some of these will have a hex reset. Some of them will have a key lock. The key for the locks depends on the brand. This is Simplex pull station, takes a Simplex key. This one right here is ADT branded, but it takes a Firelight key. This one's kind of weird. This Firelight T-bar here takes a hex wrench reset. So these are simple and easy to pull. Just pull them. To reset it, you open it like this, push it back up, close it. This one has a spring-loaded latch, which is quite nice. I don't have my Simplex key with me right now, but these Simplex one, you pull it, insert the key, turn it, open it, and the handle automatically springs back up, so you just have to close it again, lock it, and you're done. Next one we'll talk about, these Edwards one. This is a 270 GAO, but the most common ones are the 270 SPOs. I'll explain the difference, why there's a key switch on some of these, and why some don't. It's mostly a Canadian thing again. You just pull it, take a screwdriver, this flathead screwdriver, turn it left, it opens. This one you have to push the switch back down because it's a switch, not a button. Same principle though. And push the handle back up and then just slam it closed as a spring-loaded latch again. And these ones have 4 terminals, but yeah, this one has 4 terminals because it's 2-stage. Some will have 4 terminals and be single stage, but 2 pairs will be for the handle, the one side of the contact. Other pair will be for the other side of contact. It's an in and an out. Next style we'll go with is very infamous design. You will recognize this as the BG12 because that's what it is. This is an ADT BG12L because it has a key lock. You push in, pull down. These ones you absolutely have to push in to be able to pull them down. Then you just have to open it like this, close it back up because the handle will spring back up, and this one actually pushes the switch back to its reset position automatically when you close the cover. Very easy pull station to use. Very, very well-known design. Next up, here's one you might not find often, and I will go to why I do not recommend this style for beginners very shortly. This is a brake rod pull station, so it relies on a rod inside that breaks when you pull them. I will not be pulling it because I do not have a replacement rod with me right now. So when you pull them, it breaks a rod, physically breaks a piece inside. The whole front hinges out and depresses the button, causing a short. And these are not very easy to reset either, which is why I do not recommend them for beginners. Although if you're an advanced collector, these are nice because they're vintage. So this is the different styles of pull stations in general. Now, why do some of them have key switches? This is a Canadian thing, mostly. Pulling the bar will only initiate a pre-signal, so it's either going to only sound at the panel or the signals in the building are going to pulse quickly, but not often. It's a pre-signal. It indicates that something's going on, but don't evacuate yet. So now, if the responsible person goes to the location the pull station has been pulled, and there's actually a fire, they will insert a key, turn it, system goes into evacuation, signals go in temporal 3, everyone needs to evacuate. If there's no fire, the pull station will get reset, panel's gonna get reset, and everyone's gonna go on with their day without having to evacuate. This is used in hospitals, hotels, and very large high-rise buildings, because evacuating those is problematic oftentimes. This is why some of them have key switches. This is pretty much it for pull stations, because they're just fancy light switches. There's not much to them. They close the contact when you pull them, and they open it back up when you reset them. Alright, so here's chapter 9, smoke detectors. This can get overwhelming. So I'll go into detail how they work, the differences between 2-wire and 4-wire smoke detectors, and what each type of detector can detect in the type of smoke. Because yes, there's differences at that as well. It's also different brands, and I will get into addressable stuff just to explain why to avoid addressable stuff if you don't have an addressable panel of the same brand that can support the same devices. It gets complicated with addressables. I don't want to get into that in this video. This is for beginners. So I'll stick with conventional, but explain why you want to avoid addressable devices. I will now start with the different types of detection methods. These 4 right here are all what's called photoelectric. These 2 in the middle are ionization. Why are they different? Because they detect different types of smoke. And I'll explain how they do it and why do you want the 2 different types. I will be opening up the full electric one right here and explaining to you in detail how it works. There's a light sensor on this side, a light emitter on this side, light sensor on this side. Emits light, it pulses light, and it waits for smoke, dense smoke to come in, so from smoldering fires. So the dense smoke will enter the chamber, and as you can see there's ridges here, so light cannot enter the detector and cause false alarms. Once smoke enters the chamber, it's going to reflect the light from the emitter to the receiver, and that's what the detector detects for and goes into alarm. It's quite simple, but it's a very, very reliable way of detecting smoke. My favorite type of smoke detector as well. This is also because smoldering fires can be more problematic because, yes, you can see the smoke, but if you're sleeping, you won't notice it, obviously. And in a fire, it's not the fire that kills, it's the smoke. Smoke suffocation. So that is why you want full electric smoke detectors, mostly. Oh, it would be nice if I can close this back up. There we go. Ionization detectors, I will not be opening these up because it's not really possible to do so. It's also not recommended to open up an ionization detector because, as you can see, caution, radiation, americium 241. This one's a weird measurement. This one will say it in microcuries. Right here. This one only has 0.5 microcuries of americium, so it's an extremely tiny amount. Not dangerous if you don't disassemble the detector. This one here, it's a weird measurement, but equals to 1 microcurie. It's also safe if you don't open the detector up. So these use an ionization source, a radiation source, and there's two plates, one close to the radiation source and one above. It creates a current by ionizing the air between those plates, and once invisible smoke particles from fast flaming fires enter the detection chamber, the ionization particles cannot spread anymore. So the current between the plate goes away and it causes the alarm because that's what the detector detects for. So I don't recommend, well, not that I don't recommend these, but fast flaming fires are less likely to occur than slow smoldering fires. I still recommend both technologies if possible, but otherwise, if you can only get one technology, go with full electric. Now I will explain the difference between base wired and head wired detectors. This right here is a head wired detector, System Sensor 2400. Very, very iconic smoke detector. You can see positive, negative. Why only 2 wires? Because these will work only on conventional panels that support 2-wire smokes. You cannot really use 2-wire smokes without a panel. So these just take 2 wires. The zone, it's on the same zone as pull stations. There will be constant current limited 24 volts DC going to them. And what happens when these go in alarm is that it applies a resistance between the terminals. It doesn't do a direct short, it just applies resistance. Panel detects that and it goes into alarm. It's not very complicated. So this is head wired because all the wiring goes directly on this part. This is a detector head. This is a base. The wiring goes directly on the head. These two right here are base wired. I'll go with the system sensor i3 first. This is a i3 C2WBA, Canadian one, 2-wire. So as you can see, this is the base and all the terminals are on the base itself. There's metal clips here which connect with the metal pins on the head. once you actually install the detector on its base like this. I much prefer base wire detectors because they're a lot easier to install. Now I'll go into 4-wire detectors because just remember this has a relay base, so I can either use this one as 2 or 4 wire. This one's also base wired. This is called a plug-in smoke detector. This is what System Sensor calls it. This is a 2451 model. This one's a Canadian one. So, by default, this is a 2-wire smoke. Except that I have what's called a relay base with this one, which allows me to use it as a 4-wire smoke. 4-wire smokes will have 2 terminals to input power, and 2 terminals which is normally open contact, which will close once the detector goes in alarm. So instead of putting resistance across power, it's just closing a separate set of contacts that you can use with panels. Most conventional panels have an auxiliary power output. So you wire the power to the auxiliary and then the zone to the contacts to the zone in your panel. I hope I explained that correctly. So that's what it is for these detectors. Here is chapter 10, heat detectors. So, as you can see, this is basically the base of heat detectors I have out here. And they're just fancy light switches as well in a way. Heat just makes a contact close. These are all mechanical heats. Electronic heats do exist, and they work the same way as 2-wire smokes. But I will be covering mechanical heats which do not require any power to work. They just close a contact like a switch. I'll start with this little guy here. This is an Edwards 245A. This is a fixed heat detector, but this one is resettable. So if you apply enough heat, it goes off. But once it cools down, it turns back off and it's ready to detect heat again. This one's reusable. I like these a lot for fixed detectors. So these just close a set of contacts as well. So they're not very complicated. Now, all these 3 here are what's called fixed / rate of rise. I do not have a rate of rise only detector. Never mind, I do. Actually, right here. I think this is rate of rise only. It doesn't say, it's a Thermalflex branded one though. So I'll get into these ones first. These are fixed / rate of rise. This particular one's an Edwards, and as they all do, they close a set of contacts. So these ones have a disc on them. If you trigger the fixed part of these, disc flies off violently, and you cannot reset them. They're one-time used on the fixed part. What's rate of rise though? There's a little diaphragm inside made of, I believe, plastic, which with the air pressure inside, when it heats up, it causes more pressure. Like, it has to heat up at a certain amount of degrees within a certain amount of time. The diaphragm will move and close contacts. And if you don't trip the fixed part, rate of rise part can actually reset once it cools down. Unlike the fixed resettable one, which uses a bimetallic strip, this is a plastic diaphragm inside. So instead of detecting a fixed temp, it detects a rising temperature within a certain amount of time. Which is why this port there's this port on the back. There's certain air pressure inside the detector, and when it heats up, the air pressure changes, pushes the diaphragm against the contacts, and goes off. Same goes for these two. These work the same. Rate of rise only is the rate of rise part without the fixed part. So it's just the diaphragm inside. This is resettable and just closes the set of contacts as well. I believe that's about it for heat detectors. They detect heat and they close a contact. They're not complicated. These ones, since they're mechanical, you can use with just a horn strobe or something on a power supply. They don't require a panel, so you're able to use these just as a closed contact system. Alright, so I will combine two chapters into one for this one. So it's going to be chapter 11, Coding and Panels. I will start with coding because I have this smoke alarm out with me. As I did not plan this in advance and I don't have power ran to this setup right now. So this is the best I can do to demonstrate coding. Why do we have coding? It's to differentiate general alarms from fire alarms. Now alarms obviously can be continuous. There's what's called temporal 3. There's march time, which is usually 120 beats per minute. So it pulses 120 times every minute. 60 beats a minute, which is half a second on, half a second off. There's 90 beats a minute, which is slower than 20 beats a minute, but faster than 60. And there's
90 beats per minute march time doesn't actually technically exist in the wild. It's incorrectly called 90 beats per minute.
It's the simplex
2001 style march time.
Yeah,
and it's generally slightly faster than 90 beats per minute.
Yeah.
You'll of course it'll range from 90 to 100 beats per minute, with 100 beats per minute being the average for any typical march time card on any 2001 style panel.
Yeah. So, there's also 20 beats per minute, which is usually what's used as a pre-alarm signal in Canada, where it's just a slow pulse every, I think, 3 seconds or something like that.
Sometimes called slow march.
Slow march time's different. Slow march time is 1.5 seconds on, 1.5 seconds off. While actual 20 beats a minute it's a short pulse every couple seconds. At least here in Canada. So
another quick note about march time is that it's around the average cadence for someone walking with purpose out of a building, or how fast they should be walking out of a building, as to create a sort of rhythm.
That's interesting. Alright, so since I have the smoke alarm here, I'll demonstrate the most common coding. Temporal 3. Which is, here's what it sounds like. As you heard, 3 beeps, pause, 3 beeps, pause, and it keeps going. That's temporal 3. It's the most recognized coding in North America. I apologize for the cut in the video. What I was explaining is that temporal 3 is the most universal coding recognized in both Canada and the United States for fire alarm. Other countries like France, the UK, Germany will use different tones, like different sounds completely. But in North America, you will find a steady tone coded at temporal 3 most of the time. Unless you get into voice evacuation, which I will explain a little bit with panels, but otherwise it gets complicated. So that's what the Emperor 3 sounded like. It's the most common coding you'll hear, especially on your modern house smoke alarms. So, now that I got coding over, I will now explain panels. I'm not going to go too much in detail with panels, but I will explain them just enough so you know what to search for when you're searching for your first panel. I am warning you, panels are not cheap. They're not cheap at all because they do a lot. Now, what you want to find are conventional panels. What does conventional mean? It means that the devices are done. They close a contact or they put a resistor. It's a generalized zone of a building, but you don't know exactly what point activated specifically. It's a very, very simple way for fire alarms to work. It's also what you want to start out with because unlike addressable, it's not usually headache inducing to work with conventional. So conventional panels I recommend as a starter would be the Mercom FA103 or FA106. Those are as basic as you can get. If you find one, you want to pay under $299 Canadian brand new for, because I got mine from a Mercom dealer for the FA103, and that's what it costs brand new. So if you're paying more than $299 Canadian before tax for a Mercom FA103, you are getting scammed. FA106 is $400 Canadian. If you're paying more than that, you're getting scammed. More panels that I recommend are the Firelight MS10UD-7 or the Notifier SFP-10UD-7. Both panels I just named are the same exact panel, different brands. They're a 10-zone conventional panel. So you have 10 different zones you can use on the panel. They can do basic correlations, I believe. I hope so. Otherwise I'm saying trash. And correlations, what that means is that you can decide what zone activates what NAC. So it's really useful if you want to do custom things. A NAC is a notification appliance circuit. That's what you connect your alarm devices to, your notification appliances, so they work. Your zone or initiating device circuit, IDC, is what you connect your initiating devices to, like your pull stations, your smoke detectors, and your heat detectors. So it triggers the panel.
Another good panel that's good for beginners is the Simplex 4004. It has no proprietary software, and it can be programmed just using a couple buttons and a switch.
That too.
So, the entire programming menu is featured on the side of the panel.
Yeah. Another panel that I recommend, if you can find one, is an Edwards 1527. There's nothing to those. There's no programming. There's one zone, there's one NAC. If you want something really basic, really easy to use, the Edwards 1527, there's literally nothing to them. It's a zone, it's a NAC, it latches into alarm. There's an alarm relay and a trouble. It can monitor your zones, obviously, and NACs, but there's nothing complicated to them. Now I'll go into conventional panels that I do not recommend, because some of them are very complicated for beginners. Now, I don't recommend them for beginners, but advanced collectors, if you know what you're doing, go ahead. First one is the EST1, Edwards EST1. Why do I not recommend those? Because they have some programming to them. And the programming is extremely complicated. It's headache inducing. And I have an EST1. And I've messed it up a couple times while trying to program it because it is not obvious what you're doing. Next panel, I don't recommend. It's a good panel. The one I'm about to say is a good panel. It's just not for beginners. Is this Notifier System 500 and a Notifier System 5000. They're conventional panels, except they have a lot going to them. You need to configure modules. There's a good amount of programming to them that you have to do. Programming on them is easier than the EST1, yet for beginners, I do not recommend it. Why do I mention the System 5000? Because I recently got one. I programmed it. I had no issues programming it, but as a beginner, I don't recommend panels that are that have a lot of programming. Now the SFP10UD I mentioned earlier, there's programming to that one, but it's extremely easy. You see what you're doing as well because it has a screen. The Notifier System 5000 does not have a screen, it's only blinking lights and solid lights. So that's why I don't really recommend that for beginners. But there are very good panels for advanced collectors like me, where I know what I'm doing. I also worked in the field, so I know a lot what I'm doing.
More panels to stay away from are any other simplex panels besides the 4004, as the programming can be difficult, or you have to obtain a programming password, which may or may not be possible depending on where you get that, or any Edwards Fire Shield, IO, EST2 or 3, or any of the other addressable Edwards panels.
I was gonna get with addressable. I was gonna get into details with the addressable. Not full details, but a good amount just to avoid it. So you can keep going on if you have anything else to say.
More panels to stay away from is, I'm kind of on the fence with the Firelight MS2 and MS4. They are not very good panels in themselves, as they
break all the time.
Available. Yeah, they break. However, if you can find them for under $100 in working condition, they are okay to use. Just be known that they are FWR and they are not suitable for mechanical horns.
Yeah. Well, mechanical horns will work on them. They're just going to sound goofy as hell.
Yeah, they're also not going to sound good.
Yeah. So, earlier I forgot to explain addressable detectors, so I'm going to get to them with addressable panels. These are addressable detectors. You might say, yeah, they're smoke detectors. This is a heat, but same thing. So what's special about them? Why do you want to avoid addressable as a beginner? Because if you know how USB works, addressable is basically the same as USB except only 2 wires. It communicates its data. So here's a General Electric Edwards smoke detector. You may think, oh, this is a 2-wire smoke. In a way, you're right, it's 2-wire, but it's not conventional. This will not work on a conventional panel. As you can see, this one has a barcode with numbers. This is the device's serial number or address. This is what the panel searches for when communicating to the device. The addressable detectors are not what decide when to go on alarm. The panel does that. This is just a remote sensor. This just gives the panel a smoke level or a heat level. The panel decides when to go on alarm.
That would be called a peripheral.
That. I'm out of words sometimes. you can see, this one also looks like it would be 2 wires, but again, it's not conventional, it's addressable. This is a heat detector, so it would send a heat level to the panel. The panel decides what to do with it, when to go an alarm. This here is a General Electric Vigilant detector. This is a GE Edwards GSA detector. There's also SIGA, which is Edwards Signature Protocol. So these only work with the panels they're meant to go with. So these General Electric Vigilant detectors only work with General Electric Vigilant panels or Kitty Vigilant panels. The Edwards SIGA detectors only work with the EST3, EST2, the Quick Start, or the EST4 panels, which are addressable. The EST series of addressable panels, don't even think about programming them. You need to be an Edwards dealer, and you need this very proprietary software for them. The Quick Start is programmable by enthusiasts, collectors, but it's an absolute pain in the backside to do. I have a Quick Start and I don't even feel like using it. It's so bad. Just for the love of God, don't get into Edwards addressable panels, because you'll just want to jump off somewhere. Which I don't recommend doing, obviously. If ever you get into addressable panels, what you want to go with is like Firelight, Notifier, and that's basically it. Don't get into Simplex. Simplex is terrible, and that's my opinion.
Unless you know someone who can program a Simplex panel, do not get it.
And
do not get one.
Yeah, getting to know someone that can program Simplex panels in this community is difficult. So, I'm obviously not going to be naming names because I will get into shit for that. But, yeah. Simplex, I don't recommend Simplex. Like, the only Simplex things I can recommend are their conventional pull stations and their vintage devices. Otherwise, Simplex is something to avoid. Same goes for Edwards, basically. I think this is it for this video. So this will be one video with multiple chapters instead of multiple videos, because I want this to be watchable. So that will be it for this video. I hope you have a good time starting your collection if you're a beginner. So I wish you good luck. Do you have anything to add?
Have fun and buy your smoke alarms.
Fire alarms.
Fire alarms. It's not the same thing.
It's not the same thing. So, this is it, and see you in the next video.